So warm greetings, this is Team Lithium and our team ID is SIH1284, and today we will be presenting our blockchain based eVault system that we have built, and we will take you through the various types of diagrams of our project and also a complete walkthrough of the entire prototype that we have built. So now let us quickly move forward to the problem statement. And as you can see, our problem statement is from the Ministry of Law and Justice, and we aim to build a very secure record management system and create a unified platform for transparent and accessible legal record handling by providing a blockchain based eVault system. So we all know how slow and inefficient our legal industry is. The legal industry deals with a profound challenge of management of legal records. So accessible, secure and transparent handling of records is the very essence of justice, but unfortunately this leads to a lot of increased costs, it leads to delays, and it erodes the trust in the legal process. So the current system, in the current system, the documents are often misplaced, damaged, or they're simply inaccessible. And this is the problem that we're trying to solve, and our solution, which is based on blockchain, takes a step forward in revolutionizing this legal management process. Now my teammate Ronit will explain you the further diagrams.
Hello. So as we now know about the problem statement and the proposed solution, let's move forward to know some diagrams about our system. So this, as you can see on the screen, is an architecture diagram of our system. So this is a fabric network and above is a user interface thing. So firstly we'll start with the user interface. User interface is made with the help of React.js and it will be connected to the Fabric SDK. Fabric SDK holds our whole blockchain network, and the backend is made using Node.js, and it will be connected to a CouchDB. CouchDB is a distributed database which is recommended by the Hyperledger Fabric. Now let's move on to our Fabric network. In a Fabric network there will be various organizations. As you can see, this is an orderer organization. Orderer organizations is the first organization, and it creates the first block in a blockchain and it initiates our blockchain. So now moving forward to two other organizations, it is judge and lawyer, and an additional organization is client. So firstly, let's know about judge. The judge will be able to handle some various exclusive operations on the blockchain network, and lawyer will be able to handle some sub-network operations on the blockchain network. And there will be various peers in the blockchain network, which will be judge, lawyer and client, and it will be attached with ledgers and smart contracts. They will have separate smart contracts which will hold some various functions to carry out their operations. There will be eVault channel config and a network config. Both will hold their own functionalities and will be able to and will help us in operating our system in a simple manner. Now let's move on to our next diagram, which is the flow diagram, and this is the most important diagram to know our system. So now let's start. User uploads the legal documents to the blockchain, and these documents are stored on the interplanetary file system. Now uploaded documents are encrypted, and this ensures data security. The documents are encrypted using AES 256 algorithm, and we are using IPFS interplanetary file system because it helps in storing the files in a decentralized manner. That is, when a file is uploaded, it is it is deployed into different blocks, and these blocks are stored across the different networks in the blockchain. And to do all this, various smart contracts which govern access and permission for uploaded legal records are maintained. Authorized users can only decrypt and access documents as and when needed. Users can collaborate on legal matters, sharing records as required. That is, our users, that is client, judge and lawyer, can collaborate on legal matters and can share documents as and when required. Users such as judges, lawyers and client can search for and retrieve documents as and when they want, and as it is required. And the most important thing is integration with existing legal databases is also ensured to ensure the interoperability. That is, various existing legal databases which our judges want to integrate their data is which they stored on different databases can also be integrated in the system. And at the end, an audit trail records all interactions to documents and stores it securely on blockchain. as we know that audit trails and auditing is very important to know how our system is functioning and how our system is working and what all is going on in the system. So an audit trail is also carried out to know the functionality and the working of a system time to time. This was the functioning of our system, and this was the flow diagram of a system, as well as we understood what an architecture diagram looks like for a system. Now Amir, my team member, will show you the demonstration to the whole system. Thank you.
Now that you have seen the architecture of problem statement, let's head towards the deployment of our project. So first, what I'll be doing is I'll be creating a blockchain network. For that, I am in my fabric samples directory, and within that directory I am in my test network directory. So let's get started. As you can see, I am in my test network directory, and in test network directory I have network.sh file. It is basically a bash script which I'll run to create our blockchain network. So the command for it is /network up create channel -ca-s couchdb. So sorry. Yeah. So as this command is running, I'll be explaining you about what this command is actually doing. So like I said earlier, that I'll be using a bash script called network.sh, which is pre-built in the fabric samples folder while installing fabric. And after that, what I am doing is I am creating a blockchain network, or to be precise, I am initializing a blockchain network. After that, we have create channel. This command is basically used to create a new channel on our blockchain network. And after that, -ca, which is basically to indicate that we are using certificate authority in a network setup. And then after that, -s couchdb, which is basically used for saying that we will be using couchdb as a state database for storing the blockchain ledger data. And as you can see, we have two organization 1 and organization 2, and an orderer. I can also show you that they are created by using docker ps. As you can see, we have two organization 1 and organization 2, and we have our couchdb also set up. After setting up our network, what I'll be doing is I'll run a command. So basically my command is /network.sh deploy cc ccn basic ccp /asset transfer basic chain code javascript ccl javascript my channel, then init ledger. Now I will be explaining what this command basically does. As I said earlier that I am using network.sh bash script. Then after that what I mean by deploy cc is I'll be deploying chain code onto blockchain network. Then the name of chain code would be basic in our project, and after that dash ccp would be specifying that chain code source, that is this is our chain code source. And after that ccl, which is basically specifying that we are using javascript as a language, and dash c means what channel name we are using. And as I earlier showed you that we have created a channel called my channel. Then the flag -cci init ledger is used for initializing argument to chain code. Now as you can see, I'm in my backend directory, and our backend is in express.js. So let me show you our backend directory in VS Code. So as you can see, this is our directory for backend, and as you can see in backend also we have two things, and these are basically certificates for our two organization 1 and organization 2. And in future we'll be having 3 organization, one for lawyer, judge and client. But for demo purposes we have shown you 2 organization 1 and organization 2. And every time we create a blockchain network, we have to change the organization, so that because every time a blockchain network is up, a new certificate is created for organizations. So let me copy the organization certificates from our fabric sample. Now that I have copied certificate for my organization 1 and organization 2, let's start our backend. To start our backend, basically we will start our app.js. As you can see, our backend server is running on port 4000. After that we'll run our front end. Now as you can see, our front end is successfully running on port 3000. After that, let's create a user. Now as you can see, our test user is created, and as you can see, there are no records added yet for the test user. So what I'll be doing is basically showing you how we will be uploading files. To upload files, basically user will click on choose file, then he'll choose his file. Suppose let's take g20.jpg. Select, and if I'll basically first show you about the backend. This is our backend, and in our backend there's a public folder, and as you can see, public folder is now empty. There are no files in it, and after a user uploads his file, he gets a pop-up that his file is successfully uploaded. Let's check our public directory. As you can see, we have successfully retrieved g20.jpg. After a user has uploaded his file, he can also see what all files he has uploaded. As you can see, in record 1, the file name was g20.jpg, and his hash is also generated, and he can also download his file. Let's log out and let's create a new user. Now, as you can see, new user has no record yet. So what I mean is a particular user will be only seeing his or her files. Now let's head towards the backend implementation in depth. As you can see, we have app.js, which basically has these all requirements. Our requirements are basically JWT, Express, then bearer token, course for connecting with front end, then we have FS for getting files, then after we have a bunch of APIs, but before that we are doing authentication with JWT, JSON Web Token, and we also require log4j. Log4j is basically used for debugging, and we have a couple of APIs. We have upload API for uploading a file, then we have register API. Register API basically calls this function in fabric sample fabric sample. Then we have login API. Then this API is basically for getting all those files by username. So as I've said earlier that if I log in as test user 1, and I log in, I'm able to see my files. But if I log in as test user 2, I won't be able to see test user 1 files. So this API is basically for retrieving all the files based on username. So these are all our implemented APIs. Now I'll be showing you in depth about those APIs. For registering a user or logging a user in, we have this helper.js file in which we have functions for getting user info or registering a user. If no user is created yet, so as you can see, organization on wallet, you can see admin. Whenever first user is created, before that an admin ID is created with a certificate, and whenever a user is created, his certificate is also generated here. Then after that we have invoke.js. Invoke.js is basically used for running those functions that are in a chain code. Let me show you chain code. As you can see, we are in chain code. So in chain code we have two functions that are necessary. This is our dummy data, by the way. So in chain code, the one function we have is create asset. So create asset is basically used for creating a folder up in blockchain, which will store hash of our uploaded folder in CouchDB. Then we have this function read asset by owner, which I earlier showed you that it shows folders uploaded by respective owners. Then let me show you about CouchDB. And here, as I said earlier, that we have created a chain code called basic chain code called basic. So in that, as you can see, we have bunch of files. Let's see that let's see them in JSON form. As you can see, test user 1 created an asset, and that was g22.jpg, and we have that file hash as well. So this was our implementation